Okay, like so whenever you write your own UDF using Java and you build the jar and then name the jar as some here I named it as a myudf.jar file. Okay, like the first step is okay, like you need to register the jar. Uh, Registered and then the location of the jar. Okay, like wherever it is. Okay, you will give the complete path as well. Okay, and then okay, like here in this jar I do have a class called upper, and then which will take a parameter as name. Okay, like and then it will convert from the lowercase or any case of the input parameter to the uppercase. So A equal to load student data as name, char array, age, int, and GPA float. So we already know that. Okay, like we have executed this statement so many times. Okay, and the next one is B equal to uh, for each A generate myudfs dot upper and then name. So here we are passing name to the upper function. Okay, like then this upper function will return a string. Okay, like which would be um, equivalent to the input parameter corresponding value in a uppercase for the input parameter that you passed into this function. So upper will give you the uppercase everything and in the same string, and then you, inside the B you could say like a dump B. That's it. That's not simple. But here, uh, whenever you are defining this function or UDF, make sure that it always starts from the package name. So you need to start from the package name dot class. Okay, like here, for example, just like given as my UDF, and typically normally it will be like com dot company dot some Hadoop dot p dot UDF something like that. Like there will be a lot of dots. Okay, right? So you need to give everything like that. Uh, but if you have a lot of dots like package name, class name, package name, and what do you call that? Like each folder name and then the complete class name. So to avoid that, I mean to make it as a more readable, people would also use define function. Okay, like define. Um, you can use all the entire the thing, entire the notation like package name dot class folder name dot class name everything into a single word like upper. You could also define like that. Register and then define. Okay, like for example, okay, like here you could also do that after my video that upper like it. Okay, just like creating an alias name. Okay, like uh, uh, for the entire class path or to enter the class name. Okay, starting from the package. Okay. So you could also define like that. Um, for each A, generate my UDF data upper and then you pass the name. And this is a very simple UDF. And most of the cases people would use or people end up in writing UDFs for evaluation functions only. Okay, like especially. Okay, like most of the cases. Okay, like but if your project is much more complex, okay, like require a lot of input formats, a lot of things, a lot of several things, then only you will end up in creating UDFs for different things. Okay. This is a very simple way. Um, Package, of course, I defined my package as my UDF, import statements. I need not explain this. Next one, um, whenever you are defining your own UDF class, okay, like so public class, you name the class as, um, whenever you are naming the class, make sure that the class name should resemble its purpose. So here, uh, I'm looking this UDF, what it does is it will take an input string and it will convert into a uppercase. So that is the reason I named it as a upper. Some organizations will follow that UDF should be in uppercase, but I saw in both scenarios exactly right. So it's up to the developer or whoever the designer will decide that one like what is the naming convention for your UDF. Okay, like so, but here in this example, I just given as a upper. everything. Upper is in uppercase. Okay. So upper, next there is a class name. So you need to extend this, okay, like eval function. Okay, like so eval function is the class, okay, like sorry, interface, okay, like you need to remember that. And this eval function here, okay, like it's a generic name, so it takes the generic type arguments. So I hope hopefully some of you remembered our generic types and generic parameter class. Okay, like so um, anything that you put it in angular braces, okay, like it will be called as a generic argument. Okay, like so here it's passed as a string. That means where this class or this UDF is expecting input argument of type string. Okay. So that's what it is here in this one. And once you have a class, okay, the next one you need to remember is that like you need to define the execute method. Okay, like since there is an interface, so obviously we need to define some of the methods in that one, right? So one of the things is called like execute. And execute exec, okay, like this function, okay, like take a tuple as an input. So the entire tuple as an input. Even though, I mean, like here you could pass it as a, what do you say that one, like so. Here I'm passing it as a one of the field here. So the name, age, GPA, right? Name is one of the field in a tuple. But execute function will take the entire tuple as an input. Okay. Um, tuple input, I mean, if you try with something else here, the string and a string or any other input parameter that you pass it, you will see that you'll see an error there. Okay, like so. Eval function, okay, like here the execute will always expect in a tuple. Okay. And this is the function that you need to define at the end. Okay. Once you decide what is your class name, and the next one is execute. So here in execute, uh, the input is a tuple. So you could write some of the validation checkings, like if you pass it to the class, okay, like, and then, uh, or else you pass a tuple which does not have any of the fails, okay, empty tuple, okay, like then input dot size equal to 0, okay, then also like you need to return either the error or return some null or return some whatever the values, okay, like you could whatever the condition that you want to put here, you could do that one. So this is all like plain Java code. So if input is null or input dot size equal to 0 or input dot get of 0. So here get of 0 means remember pig always give you uh, positional level parameters also. Okay, like while accessing the field. So get of 0 will give you the first field in a tuple. Okay, that's what it indicates. Get of 0. Get of 0, get of 1, get of 2, get of 3, like that. Okay, like so. Um, get of 0, that means the first field that you have been passed to this class, okay, like is null. Okay, like any of these case would happen, you just return as a null. Okay, like all the error or failed cases here, okay, it is returning a null. And then it's always advisable to put everything in the try catch block. Okay, like so if any exception arises, um, so that it will be caught, and then you could take some particular action whenever that exception arises. It's always advisable to have the try catch blocks, especially while writing your UDF. The first condition, anyway, if input null or anything, this statement need not be in a try catch block. There is no um, there is no way that okay this will generate a exception, but if you want you could also put that one into the try catch flag. I mean that is also work, that also works. Okay. I mean sometimes what would happen is um, it would raise a different kind of an exception rather than satisfying or rather than going to this running it. I mean, rather than what do you call it? Satisfying these if conditions, okay, like so it will throw some other exception. Okay, like so that is the reason all the input validation people they don't put into try catch block. After that only they will try to add the try catch block. That is about the try catch. Okay, here and in the try catch block you could add as a base exception class, and you could write some you could raise as an exception. Okay, like so here got exception crossing input row and then so some people, what they do is either print stack trace also, okay, so that it will print the entire stack. People would do that one as well. And the next one, so inside the try catch block, okay, now we are um, exactly writing the functionality that we are looking at. Okay, first you try to get the input parameter. Okay, what is the input parameter that has been passed to the UDF? So here, this is my UDF class name, and name is the one which is passed. Name is nothing but it is a field. Okay, like from the alias A. Okay, like and A is again like a bag, and A bag has a set of tuples, and each tuple has a set of fields, and name is one of the fields. Okay, like so for the entire field. Okay, like so here get of 0 is nothing but okay like the first field. Okay, that's what it indicates. Okay, input is nothing but here the tuple. So you are getting the tuple dot get of 0. Okay, like or whatever it is, whatever the first value that is being passed to here. So here we since we sending as a name. Okay, like so that is the first one. So get of 0 will be the first one. You could also pass multiple things basically as an argument. Okay, like so here probably name uh, as a one argument, name plus concatenation of some other string. I could pass the second argument like that. So get of 0 will be get of 0 is the first argument which is passed to this class. Okay. Input dot get 0. Okay, like so, and then even though here it is a char array, but it's always advisable to make sure that you cast to a particular data type that you have been expecting. Okay, like so since you are calling the external API and then you are passing some other parameters, so it may be some you might be passed as age as well. So age is an integer here. Okay, right? So if you pass as the age, okay, which is in numeric or integer, um, yeah, maybe this function itself will not work because it is different as string. Okay, I'll take it back. Okay, like I mean, just we want to make sure that okay, input dot get one. Okay, like you are casting back into a string. Okay, like you are make sure that that is about uh, data type string. And due to some reason, if it is not able to cast into the string, okay, like then the exception will be raised and then you get this exception directly. Next, okay, like so if there is no exception and then we got the string, we got the str here, okay, like it is of type string, str value. And then str, what we're doing is, since this is of type string, okay, like the string class, the string default class in Java, so that has a method which would convert to uppercase. So str dot to uppercase will return you the string variable, which is the equivalent to uppercase of the given string. So str dot to uppercase, okay, which will convert it into uppercase and return a string, and then you are just returning back into the calling method or calling method. Okay. So this is a very simple UDF eval function. Okay, like it's very basic um, UDF which will be calling at the field level. Okay, like in the page. I saw so many UDFs, but most of the people write eval functions a lot. Okay, like so there may be so many scenarios where you will end up writing your own UDF. Okay, like, my first UDF in page, so we got a need, okay, to find out the coming Saturday date. Okay, like if I pass today date, it used to give me that whatever the uh, nearest Saturday date. Okay, like the coming Saturday date. The first coming Saturday date is the one which they are getting on. They do have some. They will run the each day reports. Okay, like so the reporting date it will be always run on the Saturday. So and whatever the day that you are going to run this run or call fixed rate, so you need to know what is the coming Saturday date. Okay. So for that one, we have written a UDF. There is no function is available in Pig or piggy bank or even data flow and everything. So finally, we ended up that one. So that function expects a date parameter. Okay, like so this is nothing but I'll pass this a current date, whatever the current date. Okay, like that I've been running on. So it will expect a date, some date value. Okay, like so using the date, we will find out that what is the next available solid. So that's what that PDF does. Very simple. Okay, like this only like I have written. I'll show you in the uh, Saturday class. Okay, like so, uh, but pretty much similar fashion. Okay, like nothing fancy. It's very simple Java. Any question on eval function? Okay, like if there are no questions, then we'll go. I will go to the next topic. I'll show you another UDFs, another type of UDF. Is it clear, everyone? Okay. How to compile? Right. How to compile? Like just copy. That's what I will show you in the Saturday class. Okay, like so. Um, Praveen is asking that like how to compile the code. Okay, like so. Once you write the Java code, okay, right? It's nothing fancy. Okay, like how you are compiling with the Java application, it's the same thing. It's not different from your existing or regular Java. Okay, it's a similar way. Okay, like only thing is like since you are importing this big eval function, big data tuple, so you need to have a big jar. Okay, like as one of your dependent library. So once you add the library, okay, like so then you will be good. I'll show you whatever the complete project setup as well, but um, how to compile this one, like so use a Java compiler and then you can compile the code. Okay. Any other question? Venkatesh? Okay. Next one, I'll take you. Um, what are the examples that Pig has been provided? I'm just going through that. Okay, like so. So here, okay, like so, they try to define a function on multiple rows. Okay, like which would require the multiple tuples. Okay, like so, count of A. Okay, like we already know that what is the count, right? Okay, like so, now I'm not sure whether it's flying for all of you. I'm zooming, I'm zooming in. Okay. Now we'll see that this is the like sample of pig flow. Okay, right? And count is a function. We know that like it will just count on number of tuples that you passed in a relation or in an outer bag. Okay, like that A is a relation or outer bag. Count of A means like it will give us like how many tuples exist in the A. Okay, it's pretty simple. There are two types of uh, um, interfaces that you could use. Okay, like one is that like algebraic and accumulator. We'll go through that when to use or what. Okay, like, but these interfaces, um, for example, whatever the eval function that we used here upper, for this one, there won't be any value added. Okay, like by adding that interfaces to your UDF. But there are some interfaces here, for example, the count will involve multiple tuples, right? Multiple tuples, and uh, it also requires like whatever the UDF that you want to see the progress in between. Okay, like how many rows that you already done, and you want to output any of them in between, or any logger message, anything like that. Then you need to what do you call add these interfaces to your UDF class. So whenever you are extending that eval function, okay, like add algebraic is one way. Other one is accumulator as well. Okay, like implements accumulator or implements algebraic. Okay, this is one way. Okay, like so. Of course, you could also implement both of them. So we'll see that what is the difference between one to another and way to use what. I don't have any of the slides on the UDFs because I'm not normally like even for the regular classes I don't explain a lot of things on the UDFs because these are all uh, only the people who write the UDFs if they need any of the extra functionality um, required in the field, right? So that is the reason I don't explain that one. So, but user guide has very nice information exactly like if you just read out the link that will be more than enough. Okay, the first thing is here for our understanding this eval function is taking the long, okay, like and then implements the algebraic, okay, like algebraic interface. I'll come back on that. Okay, like what is this one? What is this algebraic? Okay. Next one, long. Obviously, like whatever the type, the generic data type that you have been passing to the eval function, it will return the same thing. Okay, like public long execute, triple input, cross IO exception. This is all we already know that. And next one, okay, like here, um, here in this case, it is returning count of input. Okay, like so, count, you know that, right? It's just give the a number, a numeric number. This is of a type long. Okay, like so, long integer. Okay, especially in the Java world. Okay, like we have a long integer, long. In high or something integer or big integer. Okay, like so, the long is something like equivalent to of big int. Okay, big int of 5. So typically it takes 16 days. Okay, like, and it shows up to that information. 32 I guess. Long will take 32 days. Okay. Anyway, so it returns count of input because we are this count is a function we are writing in the Java class itself. Okay, like, and then we'll see that how to write that count method. Okay, and uh, since we are implementing this algebraic, okay, like so there are some methods, okay, like which you need to implement or which you need to write the code. One thing is called like get initial, okay, like so which will always return the string. Here the get initial means the name of the class. Okay, like so what is the name of the um, UDF that you have been using? So typically the class name would be the same. So return here um, initial dot class dot get name. Uh, anything like class dot get name. Okay, like will give you the class name in the Java. Okay, like so here for this example here it will simply okay return a count. Okay, so let's go to this initial class. Okay, like and then get name function, okay, like defined in the initial class. So here, whenever you use the initial dot class, so he is not interested in invoking any of the object, but he would like to call a particular method. So you could call them whenever the class is a static. So only if it is a static class, then only it will allow you to call a method defined in the class. So that's why he defined static public class as initial, obviously like which is also extended eval function of tuple. And public tuple again execute. Here the return, what is the tuple factory dot get instance will give you okay, like a runtime instance of that one, and then new tuple count of input. So say like initial dot class dot get name. Where is the get name defined? Any advantage of this? So basically here the initial dot class dot get name will give you the name as initial. Okay. Next one is get intermediate. Let's go to the remaining functions. We'll see that like we could be able to track that out. Next one is get intermediate. So same thing, return intermediate dot class dot get name. Okay, like get intermediate. You have the intermediate class defined here. Same thing, extensible function of tuple. Okay, like tuple. Oh, okay. I got it. Uh, and then here you got the input. Okay, like the tuple factory, like the instance, new tuple, sum of input. Okay. And then next one is the final, get final. Final is executable, return sum of input. Okay. And count. Well, the only thing is I'm looking for the final class. Okay. So here the eval function of long, which is equivalent of that, and your initial, intermediate, and then final. Okay. Now I got something. So whenever you are defining the algebraic interface, okay, like the purpose of the algebraic interface is okay, like to produce the results at intermediate stages. So there are three stages. One is called like initial stage and intermediate stage and then final stage. So whenever you are computing okay, like this function or this set of tuples, okay, like obviously like big script will be converted into a map reduce and before even to call the mapper, okay, like initial method will be called. And after completion of the mapper, okay, like the intermediate step will be called. And then like after completion of all your reducers, the final step will be called. So that's how you should be, um, what do you call it? You should be, you should be understanding that like why we require the three stages. That's available only for algebraic. Again in the algebraic, okay, like why we would go and implement the algebraic interfaces. So any of the function that we are identifying, we would like to see each stage what is the values of this. what is the value of the EDF. For example, whatever thing that we already discussed on upper, I don't require them because upper, okay, like for the entire field, okay, like even though it has several things, entire thing is being changing. So I don't want to see that intermediate level, okay, like say initial, okay, like intermediate or something like that. Like but any of the aggregation that you have been defining. Transformations, people normally they don't define the algebraic or arithmetic interfaces, but aggregate functions like count or anything like sum or average that you have been counting. So you would like to see what are the results given in the intermediate level or the intermediate stage. So that's why intermediate and initial classes. So you already see the eval function of tuple only. So and and you apply the count, okay, like on that classes, and then you generate the first initially. Only thing is I'm worrying about that why they define the count for the initial class here, but the intermediate, okay, like we given the sum of input, we'll see that what is the sum of what is the sum function, and how it is different, okay, like from the count. When you say like a count, you are getting that input that get at zero, okay, like here. Uh, Objected values, or also you could just convert into a long and then you could define a long as well. But they what do you call it? They return some more generic way. But here we know that okay, like here it's already long is the one like it is been returning that one. So input that get zero, whether whatever the type of the tuple columns that they've been passed, whether it can be a string or set of strings or set of long, the entire tuple. So that's why they put it as a generic way. They what do you call it? Um, you need not cast into a particular data type here. So just the object would be, and then the values of type object, it's just like an instance of a bag. Because you are passing it as a entire set of, okay, like here if you see this one, this A is the entire outer bag, okay, right? It is the entire bag. So the data bag is a class organized equivalent to organized to um, represent a bag data of page. So that's what like data bag is. And then data bag dot values, okay, like you could say like dot values, then it will give a set of all the array of all the values. So dot size will give you how many tuples exist in that data bag. So that's all the value to data. And if it is the bag of data bag, okay, like that is the one. That is what most of the here the example also. But that may uh, here in this code, they also written in a much more of a generic way. They able to call this count not only for outer bag and also for the map data type. That's why they define else if the values of instance of the map, okay, like then return that null on dot map of values of type. So he just converting into a map and then getting the size. So you could call this same UDF, okay, whether it is only for not only for data, not only for outer bags and also for the map data types. They made it in a much more generic way, but since our expectation is just to count the number of tuples in a given bag, so we could eliminate this also. Okay, that's about the count. Next one, come to the sum. Okay, like here in the sum, obviously, again, they are not considered it as a map. Okay, like they consider it only for the data bag. Okay, let's assume that you are getting a data bag here, input that get zero. This is also one kind of notation. This is generic notation, but he already captured back into the data bag. Next one, we know that this is the bag, and we need to iterate that. Okay, like iterate the bag, and then you see that, and you just what do you call it? Like, uh, you trade the bag and then they get the count. So here the reason, okay, like they have been iterating the entire bag rather than getting the size, uh, The only reason is it might be changing. Okay, like it might be changing whenever you're running on at like if mapper is running for 10 minutes, okay, but there is a chance that okay, like you could call or intermediate, okay, like maybe 3 times. So if the mapper is running for 10 minutes, after 2 minutes you will call this. So until that time, how many rows that you have been uh, uh, accumulated in the data bank, okay, like that many number of rows, you just iterate through each tuple and then give them a count. Okay. When you say like size, because the size um, it's all like a array whenever that you are returning the data back. Initially itself, like they will assign some size. And then dynamically after that, they will keep on increasing the size whenever it's required, whenever it's needed, or whenever some rows have been added dynamically. So that is the reason that using the size is not a uh, good choice, okay, like at least for the intermediate stages. But final and initial anyway there won't be any rows at all, so it will always be 0 and 0. So size going to the size makes sense because it's not been allocated anything like that. So at the initial time, size will always be with 0. So that will work. But intermediate stage, we always recommended define iterators and go through that each tuple by tuple and then do your own counter and then send that result. Uh, another observation here is if you look on that one, and this is a static, okay, this is a static method. That is the reason like it can be called, okay, like from the factory get instances, okay, like and then new tuple of sum. This is about algebraic interfaces. You need to define get initial, get intermediate, get final. These three. That is the only thing that you need to remember. If required, okay, like so. If you are looking, okay, like so. If you are looking, I mean, this is just like a counter. So whenever you are running an operating program, so there are some counters, okay, like which will get updated, okay, like at each stages of the map reduce, okay, like even so all the counters, okay, like they have been defined in this manner using these interfaces. So which would allow a pig, okay, like to emit whatever the information that it is being, okay, like gathered, okay, like from the MapReduce program outputs. So that is the purpose of this. And the next one is accumulator. Um, accumulator is also a very similar to like what I say, like accumulator is also a similar interface, okay, like to the algebraic, only that the methods will be the different, and it has get value and cleanup. Okay, like there are only the two methods in the accumulator interface. Okay, like but whereas algebraic has get initial, get intermediate, and get final. So accumulator has get value and cleanup. The only thing is these are the only two methods that we need to define if it comes to the accumulator. Uh, you calculate, okay, like you calculate the sum of the values, okay, like the accumulate method, and then okay, like get value. Cleanup is the one like we should call at the end of the UDF, and get value you could call at any time. Okay. So here we'll try to see something. Um, I don't have the sample. Um, Here the defined is int max. Okay, now int max is the UDF. That is a UDF class. Here implemented both algebraic and accumulator, both of them. Um, Unfortunately, they are not given any of the code base for the algebraic one. But anyway, we'll see that accumulator one. Anyway, we learned um, algebraic here. Okay, like about all the three things and all the stuff. So in whenever you define your accumulator interface, okay, like you need to override accumulate. Accumulate also will take the tuple. Okay. Here int max, I think it's trying to return what is the maximum of the integer of the tuple, probably. Okay, like that's what the int max look like. I mean, it will return the integer anyway. Okay, like so, which is this is again generic data type. Take that. This is the tuple. Okay, like max of d is an integer, and current max is equal to null return, and intermediate max equal to null. Okay, like intermediate max equal to any value, intermediate max equal to um, Java line math is between max and current max, whatever it is, and error code, string. Okay, that's good. So here he's passing a entire field and which will return a maximum integer value. Okay, that's what they define. And this is just only for our learning. Okay, like how to, this will give us an idea exactly like how to define our own, how to write our own PDFs. Okay, like so that's why they go with some very general, okay, like generic functionalities, even though the function is available in the page. Um, they're getting an intermediate max first. Initially, they defining it as a null, and current max equal to null, then return. If intermediate max equal to null, intermediate max equal to integer of min value, some minimum value that we have been assigning, and then math of max of intermediate max and current max. So for every tuple, okay, like uh, for every tuple, this code will be executed, and then it will give you the maximum of, okay, like intermediate max and then current max value. Assigning it as intermediate max. And I have no clue, but they're not at all. This is the void, okay, like accumulate, and then it will just accumulate all the values related to that, and then get value. So it is returning the intermediate max. Okay, got it. So this interface, you define and override the accumulate, and inside the accumulate function, you assign you assign whatever the variable that you want to return as part of the get value. So the get value is the one which would be called, okay, like for every stage in a MapReduce program. So if you see the output, okay, like this get value will be called for every time. So uh, uh, one way you could define it is an algebraic interface, get intermediate value and all the stuff. There's other way is also like you could also define your accumulators. Accumulator is nothing but like if you want to define your own counter, okay, like it's a very equivalent of the counters value. As you are defining your own counters, you could define the accumulators as well. Always you what do you call it, like assign some of the values for everything, okay, for each tuple by tuple, okay, like here they're getting the maximum value so far that they read. So they took this one variable, intermediate max, and from the tuple, okay, like what are the current maximum value that they will get. So they will compare the intermediate max with the current max, and whatever the maximum value of these both values, they will keep, and they will assign that as an intermediate max. That's why intermediate max equal to max of intermediate max and current max. So the maximum value of intermediate and current max will be assigned to the intermediate max. So whenever the pick is will be called the get value, okay, like it always return the intermediate max. So far, how many rows that it has been completed using your mapper phase or reducer phase? Okay, like the value, okay, like whichever to be calculated or accumulated using, okay, like this UDF will be written back to the uh, a log or program or anything like that. So for any UDFs, okay, like if you could uh, add the implemented methods of accumulator, okay, like so this value would be useful, okay, like to see the resultant at the intermediate stage. That is the purpose of the accumulator. Whereas in the algebraic, okay, like you have very limited stages at initial, intermediate, and final. There are only 3 ways. But here, accumulator, okay, like whenever you require, okay, like you could call that get value. That is the advantage. That is the difference between both of them as well. Okay. Are you guys following? Confusing? Not much helpful? Okay, like obviously UDFs will be like that only. Okay, like the simple UDFs are very easy to understand. But if you go more deeper, okay, like it will be like that only. Again, as I said, like I've not seen most of the whatever the UDFs that I have written. Okay, like I never done that. Okay, like accumulator one. How to relate this with the map reduce key value pair? How to relate this with map reduce key value pair? There is no relation between MapReduce key value pair and then your UDF. So whenever you run a pig script will be converted into a MapReduce program. So while running your MapReduce program, whenever you run your MapReduce program emits a lot of information. Okay, right? Lot of information that it will provide that. So if you are trying to get or if you are looking some information about any uh, log any intermediate information from your UDF. Okay, like then this algebraic interface or accumulator interface would be helpful. Okay, while generating or while computing, okay, like your own functionality, it also gives you provision, okay, like to emit the intermediate. Uh, what do you call it? Like your resource manager or any other. Whenever you see the logs, okay, like you could see that. For all the MapReduce jobs that you submit, you could see a lot of things, right? If you accumulator, if you accumulate, I have one more question. If you accumulate 0 is executed on mapper, what is the output key value pair? No, I mean, don't get confused. Okay, like so. Um, this is what we are talking is UDF. Okay, like so. Inside the mapper, okay, like for every tuple, okay, like this would be called. So key value pair, okay, like the output from mapper, okay, like would be key value pair. The input for reducer is a key value pair. The set of the key value pair, okay, like it's not only just one key value pair, set of the key value pair. So you are calling UDF in your pig script program. So inside the map reduce, whenever the pig converts your pig script into a map reduce, so inside the code, okay, like it uses your UDF code as well, okay, like while running your map reduce program. Okay. How many mappers, how many reducers, that's all different and that's all dynamic. That doesn't concern about your UDF service. It is will be running on the map reduce, right? So these interfaces will help you out, okay, like to emit some of the resultant, some of the intermediate values at several stages. Okay. Uh, Again, these two are interfaces will be there only for eval function. Let's go to that another one, filter functions. Okay, like so. Filter functions. Uh, Here one of the example. A equal to load student data, B equal to load voter data, and C equal to group A by name, B by name. So they're just getting all these data sets together and then they're co-grouping by. And D equal to filter C by not is empty of A. Okay. So filter C by, okay, like is empty of A. So here this is empty is a filter function. Okay, because we are using at the uh, filter operator. Okay, like so these kind of a function, okay, like if you want to write on your own, there are some is empty, is null, okay, like is numeric, okay, like that kind of a functionality if you want to write your own UDF, okay, like how to write that and what is the uh, class, what is the abstract class that you want to extend it, and what are the interfaces that will be available. So for all the filter functions, eval function, we already saw that one. So all the filter functions, you need to extend into the filter function. It's very similar to eval function as well. So you define your own class, extend filter function here. And in the previous UDFs, okay, like whatever thing we tried is the eval function, because that will be applied on the field level. Filter function, obviously there is another, uh, for all these filter functions, the only difference is that it will return the boolean. Always filter functions returns the boolean data type. Okay, and execute again the same method. Okay, like you need to override execute tuple dot input. Okay, like get that input at get of 0. It always gives you whatever the first value that has been passed. Update of values much more of a generic way. And if that is a data bag, okay, all these UDFs they written in such a way that like okay, like so they will have more suitable not only for the bag and map and anything other than that. Okay, so if it is a data bag and you pass it as a outer bag, okay, like for the isEmpty method, and then you could see that size equal to 0. So if the bag is empty, okay, like then you need to return that. It's as simple as that, right? If the bag has some tuples, then it should you should return the positive, you should return a size or you should return something else. So here, is method, it's giving the size. So if the size equal to 0, then it is returning 1. So is empty will give you the boolean value of 1. Else case, okay, like uh, if it is not, where is the else case? Uh, Else if this is the else. Okay. So in the else case, they're sending some error code of some particular number. Okay, like cannot test this one and whatever it is, like what you want it. Okay. Oh, God. So you could simulate and you could run for the several things and all the stuff. Okay, done. Next one, again, it's a eval function. So I don't want to, but it's a eval function at the bag level. Okay, not at the field level. Okay, like so that's why they make it the difference between eval function of any of the type like string or because we are expecting a bag. Okay, like tokenize is one of the uh, functions. Okay, like available in the pig, which would return a bag. That's why the return type is data bag. Tokenize, I think we already used it when we were running at the pig word count program. So whenever you uh, uh, pass an entire string and you want to make it as a tokenized, so it will try to split the entire string based on the delimiters like space, tab, multiple spaces, and end of line. All these delimiters based on that will divide into a set of strings, set of individual strings. Okay. So that's what the tokenize does. So tokenize will give you here the tokenize will give you the data bag. Okay, the entire the bag. So in that case, okay, like how to return and how to return and do that one. So you get a, I mean it's very easy instead of a standard data types. Okay, it's returning a complex data type. Okay, like nothing fancy. The next one, same thing. Here the eval function is returning a tuple. So you are swapping one tuple to another tuple. Okay, like the swapping of all the data. So that's why this eval function will return a tuple. So depending on what is the type, what is the need, okay, like whether you want to return a standard data type, whether you want to return a tuple, whether you want to return a bag, depending on that one. Okay. You could see that when all these methods, they were not implemented algebraic or accumulator one. So only the sum of the functions, uh, if it all required or needed, then only you add that interfaces for your EDF. Otherwise, you could ignore that. Uh, Tokenize again. Okay, like so. This is very good one. Okay, like so. Absolute value. Okay, like it will return the absolute value of the. If you pass minus 23.0, okay, like then it will give you 23. So it's just like an absolute value. It's uh, very easy to understand. Another one, int absolute value, double attribute, double value, like that. There is one more thing. So far we covered eval functions of all other possible return types. And the second one, filter functions. Okay, like there is a third type, okay, like which is called a load or store function. So how to write your own load or store function. So if it is a load function, okay, you need to extend the load function like this. And similarly, there is a store function as well. So if you are want to remember like peak storage, okay, like load statement, load some input path where you are loading the data, that is a load statement. Next one is store function, store into, okay, like using some peak storage again, right? Load also like uses a peak storage, okay, like so. If you want to overwrite that level, okay, like at the loading of the data or storing of the data in a particular format, or if you want to store your own format of the data, okay, like where the storage function is not available for that storage type, okay, like let's say binary zip format that you want to store the data, okay, like I don't think it has that any store method, then you will write your own store function. Similarly, in the load, if you want to read the zip files using the fixed script, so it does not have any of the load function of that particular type of the file. Then what you do is like you write your own, okay, like load function. We'll see that one too. Okay, like I don't think we do have a lot of time here. And I think yes. So this is how you define your um, alias one. So here the define max number. So r dot apache dot pig dot piggybank dot evolution dot math dot max. So this is the complete. So here the max is the uh, class name, and everything this is all like called the package. Okay, starting from the package. So wherever that you are using, so instead of give you or enter the class name, you just give max name. That would work. So which will increase the readability of the code. Uh, so Venkatesh is saying that he could not understand it completely. Uh, don't worry, I will repeat once again. Okay, like so maybe the next class also will spend more time on that one. I will show you exactly in Eclipse. Okay, like not in the web page. Maybe I'll show you, maybe that might be a little bit more clear to you. Okay. Um, let's go to the load function quickly. Okay, like then we can uh, before I leave today, I want to finish up at least something related to that. Load function. Obviously, we know that it should be extended to the load function. Okay, like, and then uh, load function, the important thing is you need to define the constructor. Constructor plays a very uh, people would write everything since this load function, right? Load function will pass uh, a parameter to that one. So here the simple text loader, okay, like which will just load that text data. Um, tab is the default separator between the fields. Okay, like the string of delimiter, obviously like there is some delimiter that you have been passed. Like pick storage of, remember like we given the comma, we given the pipe, what is the delimiter that you will be passed. So the delimiter is the one which user is passing to you in the your load function. So first check if the delimiter of length equal to 1. We want to consider, we want to see that exactly what is the length of the delimiter. And whatever it is, okay, like then you need to see that one exactly whether you have been uh, escaping, okay, any of the characters, like for any of the Unicode, typically people would escape that one. Slash U, okay, 001, slash U 002, okay, like these are the ones, some of the um, different way of using ASCII codes, okay, for these delimiters. Okay, like, and then get the byte, okay, from that size, and then you can get the get the corresponding get the corresponding value. So like here it's called like a field delimiter, and these are all like assigning in the uh, constructor of the your class. And the next one, okay, like get next. This is the function that you need to override. Get next. In the load function, right? If load, you are loading from a table, HDFS table, or HDFS file. So get next will always give you tuple by tuple by tuple by tuple. So get next will, the responsibility of the get next is to get the next tuple. Okay. And and the next one is the input format. Okay, like obviously the your input format would should give you the new text input format. Pretty much you could see the same kind of a jargon in the MapReduce program file input format. Okay, like how you are specifying to your record reader get next, get key, get next value. Same thing even in the ping as well. So the load function is pretty much will work in the same similar manner. So whenever you are loading the data, pig always converts into a MapReduce. Remember, pig converts your pig script into Java MapReduce. So jargon will look like pretty similar. Okay. Prepare to read. Okay, like so here it will take the record reader and then the pig split. Okay, like whatever the split size that you would be passing. So that much of the data it would read in one one run or in one cycle. Typically, the fixed bit if you give as like 128 megabytes, that means the entire block size that you could be able to read. And I think the data for your load function. Typically, that you will be uh, uh, passing to the location to your load. This is just like one example about the text loader. Okay, like so where you want to have it different way. Okay, like so you need to have the corresponding Java API for that one. So if Java, if you are able to read any zip file or any other some particular format, okay, like XML or something else, okay, like whatever the format that you want to format, and define the corresponding load function. Similarly, even in the store function as well. So pretty much uh, it is in the similar way. Okay, like you get all the delimiter while getting the delimiter because store function also will take your what do you call delimiter, right? Pick storage. Okay, pick storage will work as both the load and also the storage. Um, you get the delimiter, and then here get next will be there for where is that? Get next will be there only for the load function, but whereas for the store, you need to have a put function, put next, just like reverse of that. Okay, and then put field. This is just like a user defined that one. Output format, and for load function, we do have an input format. Uh, Prepare to write and prepare to read in load function. Prepare to write output format, uh, set store location, there set read location, set location. So these are the functions uh, you need to override. You want to write your own UDS or store. Okay. High level, okay, like this is about the UDS. If it is not clear, okay, like next time we'll try to take a very simple example, just eval function. Don't want to confuse with accumulator, algebraic, and all kind of extended things. Okay, try with small thing, and once it is complete, that will be good. I'll show you exactly which is the running code. Okay, like maybe the next class also will spend that. And one thing that I want to um, remind all of you that we do have a class on Sunday morning 9 o'clock. So we have missed 2 weeks, right? Two classes. Okay, like so I would like to cover it up. Okay, like because we do have a lot of stuff to cover in the Java packages. So I'm not sure how many weeks that we do have more. Venkatesh, how many more weeks that we do have classes? Or when is the last date of the semester? 4, right? Okay. So 4 weeks, typically 8 classes. So uh, I need more time. So let's have a class on this Saturday morning, 9 o'clock. So please inform all the guys, okay, like all the people, okay, like who are going to be there. And we'll, uh, this is written by me. And then like we'll go through some other example, some other user guide related things. Um, I also want to cover the scoop as well. Okay, like so high level, maybe probably one class would be enough for the scoop. So we'll cover the scoop, one or two, one or two classes for the scoop, and the rest of the things for the Java packages. So we have like 6 or 7 assets for Java packages. I think there should be enough. Okay, that's all I had for today. I know it's a lot of stuff. Okay, like don't worry, we'll try to digest a little bit slower. Okay, like in the coming week. Yeah, sure. Uh, I will also inform Chakravarti Garu on that one, on the class timings, and then probably he will send out an email to all the people. Thanks, Venkatesh, for that. Any other questions? Okay, then I would like to take sign off for today. Okay, like thanks everyone for joining. Okay, let's catch up again on the Saturday. Remember, we do have a class on Saturday morning, 9 o'clock.